Hello everyone. Today I'm going to present my final project for the Georgia Tech course of the Big Data for Healthcare Analytics. The title of the project is Mortality Prediction in ICU using lab results. So the goal of this project is compare the mortality prediction results from the study by Gasami. In their study, they use a free text notes from the hospital database Mimic 2 for predictive analysis for mortality. In contrast, this study uses distinctive ICU lab events from the Mimic 3 database for mortality prediction. One reason is because in the Mimic 3 database, the text notes are not available for those patient with disease records, so that there's no way we can really predict the or judge our model without those information. Another thing is lab events is actually the source or dependent variable for events such as prescription and diagnostics, so that we think it weighs more compared to the other events and so we can kind of explicitly study the effect of using the lab results events to predict the mortality. And in the Gasami project, they use the SMV machine learning model only. And in this project, I'm going to test multiple machine learning models and to evaluate their performance and predicting of patient mortality. So the project is a typical classification problem that to predict live or dead of a patient destiny. And this work would basically adopt two type of prediction regime. One is using a dynamic observation window, which means we change the window of the observation periods, and to evaluate how those different observation data could predict to a certain predictive window. In this case, is 30 days. And also we fix the observation window is 500 days, and then we predict further from 30 days to a year the mortality of the patient, and see if this type of prediction is also meaningful or not. The prediction results will be mainly assessed with AUC and accuracy test, but other tests will also be summarized in the end. And the infrastructure of this project will adapt a Hadoop system using Pig for ETL transformation, and for using Python for data cleaning and also predictive modeling. And this run will be run in a local cluster, has 2.5 gigahertz of CPUs with 16 gigabyte of RAM. The reason we didn't use the Amazon cluster is because this calculation including 32 iteration of peak steps that will exist the allowance for the student credits, so that but the local class actually works pretty. So the experiment design is actually pretty straightforward. That we define an observation window and a predictive window with different time lengths. For the observation window is from 100 days to 2,000 days, and prediction window is from 30 days to a year. And then we use different models to do the machine learning and prediction, and compare those windows. The data cleaning that we fetched quite a lot of tables from the mimic data, mimic 3 database, and all of the um, all of those tables were analyzed, and then the meaningful ones, including the lab events data table and date time event data table and the patient data table, that would provide all the information we need for this experiment. So that after the cleaning, that we extracted only the useful information from gigabyte, tons of gigabyte of data to a hundreds megabyte size of data. So we have the dead patient table that have the patient ID and date of dead and label as dead as 1, and then the lab event table that has the patient ID, the event ID, which means the unique ID for the lab test, and then the chart time is the time that the measurement was made and the value of the result. Um, it is also, we also filtered the lab result only use numeric data instead of other string data, because only numeric data would make a good prediction in the sense of machine learning model, and it will not confused between the numeric and string data. So we would including 7 different machine learning methods, such as logistic, regression support victim machine, and so on, and also 2 ensemble models. So the result is pretty expected, that the ADA boosting methods has the best AUC performance, and what is unexpected is that even the observation window changes, but the accuracy, the AUC will stay flat. So so which means the sensitivity doesn't really affected by the length of the data. And however, the observation window for the change for the accuracy is decreased along the increase of window. That the reason for that is there are less patients are involved in the prediction window, and the ratio between train and test actually decreased, and that's caused that. For the dynamic prediction window, that the AUC actually decreased along the increase of prediction time, which means it's getting less sensitive when we try to predict things that is too far in the future, which makes sense. And still, the ADA boosting has the best result. Keep in mind that all these different methods was being tuned so that this should be the best performance for each of the mesh methods. Similarly, we see a very unexpected trend of accuracy result, that the prediction window increased, the accuracy actually increased. The reason is still the ratio between the train data and the test data was different when they when there's when the available data was filtered through this model. So here's a summary that for the average value for each machine learning methods, and so in general speaking, that the boosting was way ahead of other methods, and shows pretty good predictive accuracy and sensibility. Compared to the original study, that the AUC between 0.68 to zero point 0.8, our result is a little less robust, but still it is in a very reasonably good range. Thank you.